Well, more definitive technology stuff. This is the amp BP9060 out of a full range tower with integrated powered subwoofer. No serial number to be found on this, so I'm wondering if this is a replacement. Height channel input only. There's the bass control. So this thing, yeah, way different than I thought it was going to be. Look at that. Switch mode power supply in a little cage. And then over here on this heat sink right there, I'm betting we're going to find a Class D digital amplifier chip right there. And hopefully that's not the problem. Well, let's give it some power and see if we get anything at all. There are some voltages noted right here on this connector, as well as you probably really can't see them, but yeah, right down there you can just barely see them on that connector. That's the opposite end of that one. So I just want to fire it up and see what we should be getting on these pins. Okay, got a voltmeter out, and the first thing I want to check is the second and the third pin right here that are just labeled ground. I just want to see if this LFE input is commonly connected, because I can use that as a voltage reference. And yes, I see 0.2 ohms. So that is going to be a good cold ground for that portion of the power supply. Let me get the meter connected and get some power into this thing and turn it on and see what it does. Okay, so I do have my meter connected between the cold ground right here, and then the positive lead is connected to the positive 12 volt nomenclature on the circuit board. Got a meter set up here in a 60 volt range. Just going to pop it on and see if we get anything at all. I did see the power supply charge, and yes, the power supply did start. That is a good sign. We do have a blue LED on the back, auto power it is labeled. And so I guess I need to get a speaker connected to this thing now and see if it makes any kind of sounds. Let's take a look at the speaker output, which is going to be those two terminals right there. And we're on DC volts. I just want to see if we have a DC offset there. And we do not. That's a good thing. Well, I guess we'll connect a speaker to it and see if it makes any sounds. Okay, I know I checked the speaker output DC level and it was 0, but what I neglected to check was the power supply output for the Class D digital amplifier, which is this connector right here. One side should be ground, and it should be connected to my terminal I have plugged in, and then the other side should be the B+, and we do indeed have 44 volts B+ going into that Class D amplifier. So let's go ahead and get some speakers connected and just see if this thing does anything at all. Okay, speaker is connected, audio source is connected as well. Power on. And I hear sound. Turn it up. So bass is all the way down at 0. It's working. Although it does sound, when it becomes extremely loaded, it becomes very distorted. I'm going to have to go back and check the emails with the customer and see what kind of problems he was having with it. But it actually does work. Isn't that something? Okay, well, going to end it here. That works. I don't know what else to do. I guess I could ESR the caps in the power supply and ESR that big boy right there. And that could be causing the distortion under load. Well, let's go ahead and do that real quick. Shut the power off. And let me get some stuff. I'll be right back. One moment. All right, so I'm just going to take the cheap way out real quick, just do a test. I'm just going to unplug this one connector. That's the power supply connector that supplies the, what was it, about 45 volts into the digital audio amp right here. So I've got my ESR meter ready right there. Let's go ahead and zero out. That looks pretty good. 0.01, 0.02. I'm good with that. And that's going to check this big capacitor right here. And I got 0.04. That is excellent. And then if I just simply do an ESR check here, and I see 0.05, that's really good. I'm good with that. So what that's doing is it's actually going back through the power supply and checking one of these two output capacitors because it is in a pi output configuration. I don't suspect a problem with the other one. Normally they're bulged when there's some kind of a problem, but as far as I can tell, this part works. I've got a feeling there must be something else to this, because is it only a height input right here? Because that is a speaker input. I'm thinking there's maybe Bluetooth or something. Why it's got the LFE? I guess it's just that, but I'm at a loss. I kind of need to look this thing up. So does it have other speakers, and where do the other speakers connect? Because I see that one small connector right there, and then there's a header and some pins, but I don't see anything else to connect any other audio sources to. And it must be that connector right there. That must feed the audio in from the rest of the system. Something, I don't know. Yeah, this part works. I'm gonna leave it at that, and yeah, that's it. Well, I guess I wasn't quite done yet, because there was actually a second box, and I opened it up, and I found a couple more, so I went ahead and labeled them 1, 2, 3 in the order I removed them. What's interesting is these two actually have serial numbers on them. This third one does not, so I'm wondering if this might have been a replacement for one of these that possibly could have failed at a different time. Anyhow, let's hook up these other two and see if they make sound like the first one did. Okay, just like the last one, 60 volts DC. I do not have speakers connected yet. Power on, and I do not see any current draw, and I do not have a blue LED on the back of the unit. I did see inrush. I did see it try to pulse on as it charged the capacitors at least. 0.16 volts on the negative 12. 0.10 on the positive 12, and I think that's power on command is good, 5 volts. Huh, does this thing have to be told to turn on? Yeah, okay, well, let's pop an audio signal into it and see if it powers on. Okay, well, I do have an audio signal going into it, and I get nothing depending on where I put the volume control. No difference. No LED. I've got my meter connected. It's over here, and as you can see, I've got 0.16 volts coming out of the positive and negative 12 volt power supplies, I do believe. Now, next question, do I have my, what was it, about 45 volts? Let's see if I can do this without dumping anything out. So I'll get you the meter right there. And then this will be the positive side. I've got 0 volts. You know what? Let's check for a short. Maybe we got a dead short and that digital amplifier is pulling that down. That is a distinct possibility. Let's get the MP3 player paused and turned off. There we go. So power has been removed for a brief period of time, and we're looking for a dead short, and I see charging, so I do not believe that we've got a shorted digital amplifier. Yeah, it's not that. So what could be going on? Is it the power supply, or is it the main board? It's kind of interesting. Well, one moment. I'm going to dig just a tad bit deeper on this and see what direction I want to go with. No diagrams and no manuals at all. One moment. Okay, power has been applied, and I know I saw 5 volts on here It's labeled plus 5V right there. I wonder if I can zoom in on it just a little bit better for you and still see the meter. Okay, that'll work. So EMP is actually temp. I can see it over here on this other connector down there. This pin is labeled plus 5V, and I'm in temp, and I do get 5 volts. Okay, now on power down, actually, do we have our plus? No, we do not have, we still don't have our plus and minus 15 volts. So I get 5 volts, and then PD should be power down, which is 5 volts, and then V on is 4.2. That should turn the power supply on if I pull it low. Well, I pulled it 3.4 volts, and I don't see any change in the current on my Variac. So that should start it, unless it's PD. This thing is acting very strange. So do I have my B plus now? No, I have nothing. And I know I checked it for shorts earlier. And nope, no shorts there. So I'm thinking I've still got a power supply problem, because this V on, I believe it is, should, if you pull it down, it should turn the power supply on. It shouldn't take less than 3,000 ohms to turn that on. That's kind of strange. Let's just, for the heck of it, unplug the power amp and see if we get anything different. There we go. And the answer is no. Do we have a short on that line? Nope. And no. So I think at this point I'm going to say that we've got a bad power supply over here. I don't feel any heat. Wonder, do we have 2.5 volts on the clock crystal? Well, 1.5. So that tells me most likely the microprocessor is running. There's no way I can read it without the scope, and I'm not going to set that up right now. Look at these. Are these 1117 ICs? 3.3. So it's 5 volts coming in and 3.3 volts leaving. And then on this one, 0, 3.3, and 5 volts. So these are both 3.3 volt regulators, and they are both, well, hopefully you can still see that, regulating. That's one at 3.29 volts. Here's the other one at 3.30. So that's pretty doggone close. And like I said, I don't know if you saw it or not, this is the clock crystal, 1.5 volts and 1.4. That tells me the oscillator is running. So chances are the microprocessor is microprocessoring down here. So I'm going to call this one a bad power supply, and then let's get number 3 up on the bench and see what I want to say about that. Okay, partway through that I lost the battery in my microphone, so some of that might be dead. I'm not sure where it went out at. But I did go ahead and check DC offset. It is good. I tested power supply voltages. Plus and minus 12 volts are perfect, and the 45 volts is close enough for me. I do have speakers connected at this point. Since there was not a DC offset, I have an MP3 player connected, and the power has been applied. And so if I hit play, I definitely hear sound coming out. And we'll turn this bass control up. And that seems to be working perfectly fine. Not having a problem there. So I'm just wondering if they clip the speakers onto these, and these aren't even connected, so this must connect into the cabinet as well. That works. Let's go ahead and feed audio in right here and make sure that we get audio out as well. So I'm going to unplug that, and I'll get some speakers, or the amplifier output, connected. One moment. Okay, so I do have a receiver connected, so let's go ahead and turn up the volume. And I do get audio out of that. Do we get bass? Yes. And yes, we do get bass. And I wouldn't expect to have that much bass. Hopefully that doesn't trigger a content match. But anyhow, this one's working. So I know number 2 is dead. I want to pull the power supply out of number 2 and plug it into number 3 right here and see if it starts that power supply, which I don't think it will. I believe number 2 does have a genuine power supply problem. But as far as I can tell, I can't find a problem with number 1 or number 3. Now, I didn't test the speaker inputs on number 1, but I assume they're going to be just fine because that's normally all passive devices. So let's get the power supply from number 2 and connect it to number 3 right here. One moment. Okay, so I do have the power supply from number 2 connected to the amp from number 3. So let's go ahead and power this thing on and see what happens. I do not have audio going into it at the moment. Okay, power has been applied. And I do actually get a light at this point. But I only have 0.33 volts and 0.11 volts on my plus and minus 12 volts. And the amp has 0.33 volts. And I've got 0 on ground. So just because I get a light back here, I do have a light, but this thing's not going to work with those voltages. 0.11 and 0.32 are now 0.27 and dropping. So yeah, that's going to be a problem. So I think at this point I need to go ahead and tear into this power supply on number 2 and see what might be going on with it. One moment. Okay, now go in the other direction. I have the power supply from number 3 connected to the amplifier of number 2. I do have an audio input connected, and I do have speakers connected. So let's power this on, and the power did get applied. Let's go ahead and hit play, and it shows it is playing. And I do have nothing. Oh, wait a minute. I'm turning the wrong control. No, I've got absolutely nothing on this one. This is the one that did not have an LED also. So I think there's going to be a problem with both the power supply and the amplifier on this unit. This one's got double trouble. So what could be going on that would kill the amplifier as well as killing the power supply? Let's go ahead and double check that we actually do have voltage coming out of here. Or going into it, I should say. And something just happened. I heard a pop in the speaker. I've got amplifier voltage, 44 volts. I guess I should move that so you can actually see it. Sorry about that. Once again, I do have amplifier power, 44 volts. And this will be my negative 12 and my positive 12. And so the power supply in number 3 is successfully powering on number 2. But number 2 does have a system control issue because I've got no blue LED and I've got no sound. So at this point, I'm going to say 1 and 3 are good, and number 2's got the big problems with both the power supply and with the system control board, which is going to be a stretch to repair with no diagrams and a low-level system control issue. So I'm going to talk to my customer and see what he wants to do. Okay, now I thought I'd go ahead and test number 1 just to make sure that the speaker level inputs do work correctly. Power has been applied. I did see the power supply start, a small bump in current on the variac. And I do have the blue LED illuminated as well. So I do have my receiver connected to it via the speaker level input, and we'll put audio into it here. And yes, it is working. and they're just talking. There's some music. And yes, it is working. Okay, well, that is going to be it. So number 1 and number 3 work perfectly. Number 2 does need a power supply repair in addition to some kind of a main board issue. Maybe it corrupted the EEPROM because of the power supply issue when it failed. I think I will go ahead and tear the power supply out of it and just ESR some of the capacitors, because it's a possibility if it's got bad caps, 1 and 3 could be not far from failure as well. And that's probably what I'm going to suspect. What are the chances of getting a power supply fault and a mainboard fault on the same amplifier? And it does not look like it had ever been tampered with. So let's go ahead and pull the power supply off number 2. I got some time to kill tonight. Tear it apart, see what it has to say. Okay, well, I have the power supply board out, and I just want to give a sincere thank you to Definitive Technology for applying this surface with heatsink compound. Really, really appreciate it getting on my hands. But nevertheless, it is out. Now I've got to go ahead and get it out of this little frame thing that it's in. So there's the AC power going in there. Then this is simply a switch on the back of the unit to completely remove power. Well, let's see if this part is going to come apart peacefully. So it's got those 2 that I can see easily. And, oh, it's got a couple here. How nice. Okay, got, oh, standoff. Oh, well, okay, well, I guess I didn't have to take those off. Okay. Standoff, off. I think it's just this rubber pad basically holding this thing down. Oh, I hear it starting to give. I just don't want to break the board. Wow. I mean, really? Double-sided adhesive? Oh, finally. And one of them let go at least. Hopefully it didn't take any surface mount components with it. Holy moly. I'm pushing on just the heat sinks only. Man, that one is on there. I hear it trying to release. Man, this thing is on there. Oh, finally. Holy crap. I'm sure it took off 12 components with... Uh-oh. What's that? That's not on the back side of this, is it? I do see some dark spots right there. All right. Let's enable the macro zoom. One moment. Oh, no. I thought that was a bridge rectifier at first. You know what that is? Those are the emitter resistors for the power output FET for the main power supply. So I believe that is the FET, those 3 terminals right there. And then these 4 resistors are the emitter resistors. So I'm betting we're going to find a shorted FET right there. One moment, let me zoom out and get the ohm meter in view, and we'll do an ohm check on that FET that is just simply labeled D3. And if that's D3 right there, it doesn't look too terribly good. Let me get a light and shine on it. Yeah, it's got a divot and a crack in it. That's not good. Well, let's go ahead and check that FET and see what it has to say. Okay, ohm meter is in view. I have it on the diode range right there. Short the leads together. I get 0.000. So this is going to be drain and source, and I get 0.00. Let's go to ohms. First, lead integrity, 0.02 or 0.2 ohms and 0.2 ohms. What about gate to source? And 0.3 ohms. That's where that diode is right there. And I bet we're going to find a open diode at the same time, or shorted. Short. Good on that one. So that lead must not be used. It must be just a single direction diode. And oh no, macro zoom enabled. Right there in the center of the screen, that IC chip doesn't look too bad from this angle, but wait till I add some light to it. It's got a second Grand Canyon built into it. And all I can see is 269 CP, 269 CP, and possibly something 182. I'm not 100% sure. But yeah, it's got a divot the size of the Grand Canyon. That resistor that's right above it, that's right now in the center of the screen, it's got a chunk missing out of it. That 47 ohm right there has a little spot on it. We know that diode D3 is bad, the main FET's bad. All four of these current limiting resistors have been blown up basically. Well, I'm going to go out on a limb and say that's why it's not going to start. In addition to the problem that it has on the preamp board or the power amplifier board, the main system control board. Other side, if it'll focus. So right there is the FET that is defective. And I don't see any spots in it. But I thought, you know what, let's go ahead and check these capacitors. And there is some glue, and it is turning a little bit darker brown than I'd like to see, but it's more of a transparent glue, so I don't think that's going to be the issue. Well, let's go ahead and check these caps while we're here, just for the heck of it. Let's zoom out. And I'll get the ESR meter out. We'll check every cap on this board. In circuit, I'm not going to unsolder like these outputs, but in circuit we'll test them and just see what they have to say. One moment. All right, I did go ahead and previously zero out the leads. And so these are the two, I already bumped it, AC input filter caps, 0.08 and 0.07. I'm okay with that. Now, I have not checked the value of these small caps. I just want to ESR them, and if we find any that are like 68 ohms or anything like that, that would be suspect. As long as I'm seeing good low values. There's a 1.1, a little bit high, unless it's only like a 0.47. That's a 3. And that's a 1 microfarad. I'm good with 3 ohms on a 1 microfarad. That one's a 22, and would that read 1 ohm? Yeah, I'm okay with that on a 22. Let's see, I think I checked that one, 0.6. Now on to this side. Hopefully you can still see everything. 0.15, 0.15, 0.12, 0.7, 0.12, 0.10. These are going to be the main output filter caps. 0.02. There's one there, and then here's the other one right there. Oops. There we go, 0.02. Every cap tests okay. I don't think I missed any of them. And no, the ones I'd be concerned about are these little guys right here. And we'll check those 4 once again, just to make sure. 0.62. This one's mounted diagonally. 0.19. 1.1. I think this one was about 3.5. And there's no really super big caps. There is a 4.7 right here at probably 250. And that's the one that's mounted diagonally. As I recall, it tested just fine. Yes, 0.2 ohms. I'm fine with that. So I'm going to say, at this point, I don't know if I necessarily have the time and the resources to invest in trying to figure out what value these are and what the part numbers are on these blown up components. We know for sure that it's got a shorted FET that lives right there, the main power supply driver. Now the standby power supply did work in this, as you recall. That's that little transformer, and that's the driver for the standby power supply right there. So what happens is the 5-volt standby runs at a very, very low current, so low wattage consumption. And then when the microprocessor commands the main power supply on through these opto isolators, it begins to run this big transformer, which is what actually supplies all the power to the power amplifier and whatnot for the high power version. That way they meet the Energy Star compliant. And you can see this one is checked with the 200 watt tick box right there. But that's it. I don't think I can fix this, especially, I mean, I can probably fix this power supply, but it's going to be cost prohibitive at this point. As far as the main board goes, it's definitely got another problem, possibly caused by the power supply, spikes or whatnot. Hard to say. I don't know. But yeah, I don't think it's going to be cost effective to repair number 2. Besides, number 1 and 3 work just fine. And if I would have seen failing capacitors on this board, I probably would have addressed number 1 and number 3 if they had, suspect parts that may prevent it from happening in the future. But okay, that's it. Finally, the end of, what the heck was this? A Definitive Technology BP9060. And then there's the lovely heatsink compound they attached. Perfect. And there's a view of the amplifier board right there. Okay, that's it. Everyone have a great day. Once again, I really appreciate the views, the comments, the support. Have a great day. Bye-bye. Once again, thanks for watching. Really, really appreciate it. Have a great day. Bye-bye. Okay, with the same zoom settings, this is number 3. Let's power it on. Power has been applied, and we got a blue light. So that part works, just for the heck of it. Let's go ahead and check some voltages. We'll check them. Let's see, hopefully you can see them there. Just for the fun of it, we'll know what these things are supposed to be. This is temp, and we got 2.8 volts. It must have a thermistor in here somewhere. Plus 5 is 4.9. Power down is 4.9. And V on is 4.2. Yeah, the power supply should be running there. On this board, it's labeled plus 15. On the other board, it's labeled plus 12, but we have 11.4 and negative 15. And then this is the feed to the Class D. Really? They got scooted over there? All right, freaking pause it. Okay, so I do have the power supply from number 3 connected to the, the power supply from number 2. Let's start that over. And we'll move forward from there. If there is a part 2, I don't know. Everyone have a great day. Thank you for watching once again. I really appreciate it. Bye-bye. Okay, and I thought I'd go ahead and test number 1. Let's take that again. Well, I got the power supply off. Try it again.